Today we're going to take a look at area between curves and how we can calculate that. Basically, whenever we are looking at area over an interval, so let's say we're on the interval a to b, then we need to take the integral from a to b of the upper function minus the lower function. Okay, so upper minus lower. Sometimes we will be given a graph. Sometimes we'll be given different functions. Sometimes they'll give us the interval. Sometimes we'll have to solve for the interval. So there's a variety of scenarios that can come into play whenever we're trying to find area of between two curves. Let's start with something pretty basic when we're finding the area when we're finding the area between maybe a curve and the x-axis. That's probably their easiest type. So let's say that we want to find the area bounded by the graph of f of x equals 4x minus x squared and the x-axis. Okay, so this is definitely one that might be considered calculator inactive. So knowing your basic graph shapes can be really important. A lot of stuff randomly shows up. 4x minus x squared, that's a parabola. It is opening down because we have a negative with the x squared. We know that it would hit the x-axis when the function is equal to 0. So if we set 4x minus x squared equal to 0, take out an x, and we'd have 4 minus x. So we know that this is going to have zeros at 0 and 4. Okay, forgive my extremely rough drawing. So 0 and 4. We want to find the area between this parabola and the x-axis. So those are actually our bounds from 0 to 4. Okay, so now set up an integral from 0 to 4 of upper minus lower. Well, the lower function is just 0 because that's where the x-axis is. So it's just 4x minus x squared. We don't have to put minus 0. If we take that integral of 4x gives us 2x squared. Integral of x squared gives us x cubed over 3. And we're going from 0 to 4. Okay, let's plug in. If we plug in 4, move this down a little bit, we have 2 times 4 squared minus 4 cubed over 3. If we plug in 0, we get 0, so that works out nicely. Okay, 2 times 4 squared would be 2 times 16 would be 32. Minus 4 cubed is 64 over 3. 32 minus 64 over 3 is going to leave 32 over 3. So the area between those two, or if you're using a calculator, around 10.667. Remember, we always round to 3 decimal places if we have a calculator question. That would be the area contained between this function and the x-axis between 0 and 4. Okay, let's try another one that might be a little bit more in depth because we might have to solve for the bounds and we have 2 different functions as opposed to having the x-axis. So let's say we want to find the area between f of x equals 2 minus x squared and g of x equals x. Okay, first of all, let's think about what these look like. Again, this is definitely a question that might be considered calculator inactive. You can do this one without a calculator. So it's good to know what your functions look like. 2 minus x squared, it's opening down and it's moved up 2 units. Okay. Again, forgive the rough drawing. And then g of x equals x, that's just a linear function, slope of 1. Okay, so we're trying to find this area contained between those 2 graphs. Okay, so what we've got to figure out is where are these two equal to each other? Because those are going to be our bounds. Those are going to be our x coordinates of our limits of integration. So let's figure that out by setting these two equal to each other. Let's set 2 minus x squared equal to x. So let's move over here. So we get a positive x squared plus x minus 2. We could factor this, x plus 2, x minus 1. So that would be when x is -2 and x is 1. So this goes from when x is -2, when x is 1. Oops, 1 right there. Okay, so let's set up our integral. The area is going to be the integral from -2 to 1. Those are our bounds that we just found. And we want to take the upper function minus the lower function. Okay, we've already graphed this out. We know what it looks like. But let's say that we weren't quite sure what the graph looked like. And we found the 2 points that they had in common that are the bounds for this area. We could quickly plug something in between those that to see which one was higher at the time. So let's say in between -2 and 1, let's say we plugged in 0. If we plug it into f of x, we're going to get 2. If we plug it into g of x, we're going to get 0. 2 is higher than 0, so f of x is higher than the other function on that interval. Okay, that's another thing you can keep in mind, a small trick to figure out which is upper and which is lower. Okay, if you don't know exactly what the graphs look like and you don't have access to a calculator. So we want to take f of x minus g of x. So we want 2 minus x squared minus x, because it's always upper minus lower. So let's take integral. Integral of 2 gives us 2x. Integral of x squared gives us x cubed over 3. Integral of x, we've got minus x squared over 2. And we're going from -2 to 1. So now let's plug in. Move this down a little bit, give us a little bit more room. If we plug in 1, then we're going to have 2 minus 1/3 minus 1/2. Plug in -2. We have 2 times -2, which is going to give us -4. Then we're going to have minus -2 cubed, so over 3. So plus 8/3 minus -2 squared would be 4 over 2 is 2. Okay, let's do some combining. 2 minus 1/2. Notice that the -1/3 minus 8/3, that'd be minus 9 over 3, which becomes a minus 3. So we're going to end up with 9 over 2, or 4.5. Okay. All right. That would be the area contained between those two functions. That's a very typical type of problem, especially on an inactive section of the AP exam. You have to solve by setting these equal to each other to find the bounds, and then realize which one's upper, which one's lower, and subtract inside your integral. Okay. Let's try another one. Okay. This time I want to try one that is calculator active. Okay, so we're going to have to use the calculator to solve. Okay, so here's what I'm thinking about. Let's see. We're going to try to find the area of the region bounded by, let's see, what graphs do we want to use? Let's use the y-axis, the graph y equals cosine of 2x, and the graph of y equals 2x. Okay, so this would be one that would be calculator active. Okay, so you're going to be looking at your calculator to find maybe your graph. You want to see what this looks like, so you might plot your cosine of 2x, see what that graph looks like, plot your 2x. I mean, you should know what that looks like, but you might not know where they intersect each other. Okay, so if you go to graph that, let's think about what we have. Obviously, we know where the y-axis is. Cosine of 2x, okay, we're going to be periodic, okay, starting at the x-axis, or starting at the y-axis, sorry. Y equals 2x. For that one, we have a linear function. Slope of 2 goes through the origin. Okay, so the area bounded by these three things would be here. Okay. Now, we know where we're going to start. The first number is 0. Our interval starts at 0 because that's where the y-axis is. Okay. What we have to now figure out is, where is this intersection point? Where are cosine of 2x and 2x equal to each other? So that's the first thing that we got to figure out. Okay. If we take a look, we can graph and find where those two intersect. Okay. So if we go to our graph, and graph, you probably already have to take a look at what these functions look like, but put in cosine of 2x and put in 2x, and then we can trace the intersection point. When we do this, we should get the intersection point to be 0. And I'm going to use several decimal places because I will tell you guys, I don't like to round early, because if you round early, sometimes that will throw off your answer. And so I go quite a few. So this is at 0.3695. 4257. Okay, so let's find our area from the 0 to 0.36954257. And we want to do upper minus lower. Now on this interval, the upper function is cosine of 2x minus the lower function, which is 2x. Okay, we could take this one by hand, but since it's calculator active, we could let our calculator do the work for us. Okay, in your TI-89s, if you select F3, the second one down is an integral. It comes up with integral of parentheses, and then you would type in cosine of 2x minus 2x, comma x, because that tells it to take it with respect to x, comma 0, comma 0.36954257, close parentheses. That's going to take the integral and it's going to make it the definite integral. You got to make sure to put in your bounds in order. 257. Okay, when we do that, we end up with 0. Whoops, can't write today. 0.2002. So 0.200. And again, we always round to 3 decimal places for the final answer. So we don't have to go any further than that, whether it's multiple choice or free response. We don't have to go any further than 3 decimal points for the final answer. I will tell you, sometimes it doesn't change your answer to round early with your intersection points, but I think it's always better to be safe than sorry. You can copy and paste, remember, with your calculator. So if you need to do that, if you have to use it for more than one problem, that's a good idea as well. And again, since this one is calculator active, we could let the calculator do a lot of the work for us, which works out nicely. Okay, let's try one more calculator active. Y equals 1 plus cosine of e to the negative x. Y equals 0. X equals negative 1/2, and x equals 1/2. Okay, so for this one, they basically gave us the bounds. We know we're looking at the region between x equals negative 1/2 and x equals 1/2. Now let's go take a look at what the actual function looks like. If we graph this, okay, if we take a look at what 1 plus cosine of e to the negative x looks like. Okay, so let's talk about what this looks like. We've got a lot of, if you zoom out, this looks pretty crazy, but we do have a piece that looks like this. Okay, I'm not looking at anything to the left of that. Okay, so now let's talk about from negative 1/2 to 1/2. We have the same upper and same lower. The upper is the 1 plus cosine of e to the negative x. The lower is y equals 0, which is the x-axis. So this is an easy one. Area is the integral from negative 1/2 to 1/2 of 1 plus cosine of e to the negative x dx. Again, we're going to use our calculator to evaluate. If we plug in, hit again back in our home screen, F3. The second one is the integral, 1 plus cosine of e to the negative x. Close those parentheses, comma x, comma negative 1/2, comma 1/2. Close parentheses. That's going to find us that value of that integral. I would actually just go ahead and put it in as negative 0.5, comma 0.5. When we do that, we get 1.483 as that area between those two functions. Okay, between the y equals 1 plus cosine of e to the negative x and y equals 0 on the interval negative 1/2 to 1/2. Okay, that's what I was talking about when I said sometimes they'll give you the interval. Okay, sometimes they'll give you the bounds. So we didn't have to actually solve for the bounds. We needed to know what the graph looked like. We may have had something where we might have passed below the x-axis during that, and we may have had to find an intercept, but in this case, we didn't go below the x-axis on that interval, so we didn't have to do anything there with that, okay? Again, knowing what basic graphs look like for the calculator inactive type questions is very important. So knowing what your basic parabolas, your x cubed functions, things like that, what they look like, even some of your e functions, knowing what a basic e to the x or e to the negative x looks like can be really important, because a lot of times those are the easy type functions that they'll use in the calculator inactive section. Okay, being able to solve for where things are equal to 0 or where things are equal to each other become very important for the calculator inactive section as well. On the calculator active section, it's a lot more about knowing how to use your calculator to get an answer, or knowing how to use your calculator to find intersection points in order to take an integral. Okay. We're going to have quite a bit of practice on this, so make sure that you're working through those practice problems to get ready for everything else.